Okay, let's give you guys some more practice. So here, find the derivative of square root of x. Okay, so find dy by dx. So start out by sketching this graph here. That would give you, roughly speaking, it would give you this here. And then start out by saying the gradient, start out by saying inside your mind, the gradient that exists between a and b is given by this here. And then as you take the limit as h approaches 0, it will give you the true gradient. So the true gradient is given by this thing here. Now remember that your original equation is y equals root x. So when you come to do your x plus h here, our original equation was y equals root of x. But when you put x plus h into this x here, it will then give you this. It will then give you this here. Okay, and then this f of x here is your original equation, so that's just simply root x. And then somehow really the answer to the question, find the true gradient of y, which is dy by dx, is you trying to work out the limit as h approaches 0 here. So somehow work out this here. And remember, in the previous playlist, we did lots of examples on limits. And when you come to this, when it comes to this stage here, if you simply put 0 into the h, you're going to get 0 over 0, which doesn't really make sense. And whenever you have this here, we always times the conjugate of this. I don't know if you can remember when well, if you don't understand this, then maybe you can track back to one of the earlier videos on limits. If you want to take the limit of this as h tends to 0, you've got to use this trick here where you times top and bottom by the conjugate of this, meaning that well ages ago in the equation in one of the earlier playlists, I stated that if whenever you have something like this here, where this is easily square rootable and this is easily square rootable, and you've got a minus in between, then you can immediately jump to this plus 3 and then x minus 3. And whenever you have this plus 3 and minus 3, when you come to multiply out the brackets, it simply kills the 3x and the minus 3x. They're going to kill off each other, giving you a nice, neat x squared minus 9. This here is similar to this here, meaning that whenever you have this here, times the conjugate, times top and bottom here by the conjugate of this here. Okay, so here you would times top and bottom here by x plus h, and then instead of a minus here, you would have plus root of x, and then at the bottom do the same thing, times top and bottom by x plus h plus root of x. So really you're timesing top and bottom here by the same thing. Okay, and the thing is, when you do this here, this times this, and then later this times this, and then later this times this, and this times this here, it really tidies itself up. So, well, anyway, find the limit of this in a way. The original question was find the derivative of y equals 1 over x, but really it boils down to you trying to work out this here. Okay, so press pause and have a go. Okay, so to do this here, you would times top and bottom by the conjugate of this thing here. So that would be x plus h, and then plus root of x. Okay, and then times x plus h plus root of x. Okay, and then that will then take you to this here. When you get this times this here, it's like you having square root of a bubble timesing the square root of the exact bubble. That leaves you with just the bubble. It's just like you doing square root of 2, and then you square it, or you times by itself. That will give you just 2. So the point is that when you get this times this here, it will just simply give you this bubble here. Okay, and then remember, you've got this times this, and then later this times this. These two will kill off each other. Okay, and well, and then the second part is this bit here. This, oops, hang on, but bear with me. And then the second part is to get this bit times this bit here. So square root of x times the square root of x, that will just give you x. Okay. Well, timesing the conjugate will give you this, and then this times this whole bubble here will give you h times the whole bubble here. Okay. Well, anyway, so here timesing top and bottom by the conjugate of this here will actually give you this. Okay. And then your next step is is to notice that this. Oh, by the way, if you don't understand this step here, it's because I do it the long way if you must. So if you do like this, plus h and then plus root of x here, do this times this, and then this times this, and then this times this, and then this times this. Later you will see that it will tidy itself up. Okay, if you didn't understand that step there, take the long route. Okay, well, anyway, this from here, our next step is this thing here, and notice that this x will cancel out with this x here. Okay, so that will just simply leave you with h over blah blah blah, and notice that this thing and this thing, you can think of it now as a 1 times an h. So these two will kill off each other, leaving you 1 on top, and then the bubble at the bottom here. Okay, and then now take the limit as h tends to 0. So as h tends to 0, this bit here, as h tends to 0, it's really it really becomes this here. Okay, so now you've got this thing here. So it's like remember, x squared is like one thing, x to the power 3 is like another thing, x to the power minus 1 is another thing. Well, x to the power of a half here. Remember, square root is really x to the power of a half. So you've got one thing here, and then you plus another thing. That will give you 2. Well, basically, this bit here will boil down to this, because you're saying, it's like you saying one elephant here plus another elephant here. It gives you 2, whatever this is, elephants. Yeah. So, well, this thing here becomes this thing here. Okay. So the derivative dy by dx of y equals 1 over x actually is this thing here. Okay. So when you look at the graph here, it will look like this. By the way, whenever you're trying to find out the derivative of something, if you don't understand what I'm about to say, don't worry about it. Whenever you try to differentiate something like this, hang on, x to the power of n, whenever you want to try and differentiate this here, whenever you want to find out, suppose you have y equals this thing here, suppose you want to know dy by dx here, well, it's always you taking this down here, so it becomes this n and then x, and then this n gets decreased by 1, so this will then become n minus 1. Okay, so for example, if you try and find out the gradient of this here, okay, suppose you have this here, this will then, well, dy by dx will become, well, take this 3 out here, so it becomes 3 and then x, and then decrease this 3 by 1, so that will give you this. So dy by, well, it doesn't matter if you don't understand this, but my point is that earlier I gave you y equals x. Well, I said find the derivative of square root of x. Well, square root of x, you can write it as this, to the power of a half. Okay, so if you want to find it, so you can think of it as y equals this. So dy by dx here is, well, you take this half out here, So this will become a half, and then x, and then you get the half take away 1, which, well, a half take away 1 will give you a minus a half. So, and as it turns out that this thing here is exactly the same as this, if you think about it. Okay, so at the moment we've got 1 over, we've got this here, minus here. So you can imagine this as being one thing multiplying to the top. So that will give you x to the power of minus a half over 2, because it gets multiplied to the top. And then from indices, whenever you have whenever you have minus to the power of minus something, you can jump to 1 over x to the power half. Notice that the minus goes whenever you have 1 over something, and this here, so this is exactly the same as this. And if you don't understand this bit, you have to watch the section on indices. So over 2 here. So here you've got a fraction within a fraction. So visualize it as this here. Hang on, let me get rid of this. And then hang on, and then visualize it as this here. So you have 1 over x to the power half divided by 2. So rather than trying to do this here, visualize it like this. So here it gets multiplied to the bottom. So it becomes 1 over 2x to the power of a half. And to the power of a half is really, to the power of a half is 1 over 2 root x here. Well, what I'm trying to say is that this thing here is exactly the same as this thing here. Okay. Well, anyway, the answer to the whole question, dy by dx here, is given by this here. And when you look at the graph, it will look like this. Your original graph, the red line here, y equals root of x, it will look like that. Notice that the gradient is always positive. Always positive. But the further you go out to the right, the shallower the gradient becomes. It's heading towards 0 in a way. Okay, that's why when you look at the gradient graph, which is a blue line here, it's steep. It's steep. Well, as you move, it's steep at the start. Well, looking at this graph here, when it's near 0, it's quite steep. That's why when it's near 0, the gradient graph is really steep. It's somewhere up here. Okay, and then as you head towards the right, it becomes shallower and shallower. So when you look at the gradient graph, it becomes smaller and smaller and smaller and smaller as you go out. Okay.